Hi students, we are going to solve question number 1 in the exercise 1.2. There are 5 sub-questions in this question, and the question says express each number as the product of its prime factors. Let us take question number 1, 140. To find the factors, you put the blocks like this. 140 goes from 2 now. 2 into 7 is 14 and 0 as it is. Again, it can go by 2. 2 into 35 times is 70. Now it doesn't go by 2. You take 5. 5 into 7 is 35. Now further, you need to only go by 7. 7 into 1 is 7. Now write down the factors of 140. 2 into 2 into 5 into 7. These are the factors of 140. Now you take the second one. This is the answer. Now take the second one. That is 156. Let us do the same way. Write down 156. It also starts from 2. 2 into 7 is 14. Carry 1, it becomes 16. 2 into 8 is 16. So 78 times. This is again even number. We can try with 2. 2 into 3 is 6. Carry 1, it becomes 18. 2 into 9 is 18. Now further, you cannot go with 2. You try with 3. 3 into 1 is 3 and 3 into 3 is 9. Further, you cannot have any other factor. You have to try with 13. 13 into 1 is 13. Now you have arrived at the factors of 156. 2 into 2 into 3 into 13. 2 into 2 into 3 into 13. This is our answer. The third one is 3835. 3825. Again we go with the factors. Let us take 3825. Put blocks like this. You can try with 3. Let us try now. 3, 1 time 3, 2 times 6. You have 2 more here. It becomes 22 and it is 7 times. 3 into 7 is 21. You have 1 more here. Carry 1 here. It becomes 15. 3 into 5 gives you 15. Now we can try with 3 again. Let us try now. 3 4 times 12. Now 3 into 2 times is 6. You carry 1, becomes 15. 3 into 5 is 15. Now further, it doesn't go by 3. You have to try with 5. 5 into 8 is 40. You have 2 more here. 2 in 5 is 25. 5 into 5 is 25. Again try with 5. 5 into 1 is 5. 5, 7 is 35. You have come to the end. Now we have to try with only 17. 17 into 1 is 17. The answer is the factors of 3825 are 3 into 3 into 5 into 5 into 17. 3 into 3 into 5 into 5 into 17. You can also write down, square them. 3 square is 5 square into 17. Even this can be the way to write. So this is the answer for the third sub-question. We go for the fourth question. Is 5000 5. Let us go to factorize this. By the very look itself, we know it goes by 5. 5 into 1 is 5. Brings two zeros as it is. 5 one time is 5. Now further, it doesn't go by 5. It cannot go by 6. You try with 7. 7 one time is 7. There will be 30. 7 into 4 is 28. It becomes 21. 7 into 3 gives you the answer. So 7 into 143 is this. Now we can try with 8, no, 9, no, 11. Let us try with 11. 11 into 1 is 11. You have 33. 11 into 3 is 33. You cannot have any other factor. You only have to try with 13. 13 one time is 13. Now the answer is 5005. Factors are 5 into 7 into 11 into 30. This is your answer. Well, the last question is 7429. To find out the factors of 7429, you can start with 17. 17 4 times, you get 68. And then you can try with 3. 17 into 3 is 51. And balance is 11. 119. 17 7 times gives you the answer. Now further, you can try with 19. 19 2 times gives you 38. The balance 57 goes 3 times. 19 into 3 is 57. So further, you have to only divide this by 23. You get 1 as a reminder. Now 17, 19, 23. These three are the factors of 7429. Let us write down. The factors are 17, 19 and 23. This is your answer. Now we have solved the question number 1 of exercise 1.2. Well, students, we move on to question number 2 of exercise 1.2. The question is, find the LCM and HCF of the following pairs of integers and verify that LCM into HCF is equal to product of the two numbers. We have 3 sub-questions. Let us try one by one. The first question is 26 and 91. Let's find out the factors of 26 first. You try with 2, it goes 13 times. 13 into 1 is 13. Therefore, the factors of 26 are 2 and 13. Now you find out the factors of 91. The same way, you try with 7 into 1 time is 7. You have 21. 7 into 3 gives you 21. Now further you cannot try except 13. 13 into 1 is 13. Therefore, the factors of 91 are 7 into 13. The next step of answering is to find out LCM and HCF out of these two set of factors. Find out LCM. All you need to do is find out what is common. Mark that. Here 13 is common. It appears in both the lines. Write down that only once. 2 doesn't appear here. Therefore, write down 2, 2. 7 doesn't appear in the first line. So I have to write that also. Now when you multiply, you get 182. LCM of these two numbers is 182. And HCF is very simple. Whatever is common, that is the HCF. This is the HCF. Now, when you multiply these two, what do you get? Let us write down that LCM into HCF equals 182 into 13. When you multiply this, you get 2366. Now this is our first answer. Now let us try to multiply the numbers 26, product of 26 and 91. Right? We write down 26 into 91. When you multiply these two numbers, you get again 2366. This is our second case. By this observation, you find that the product of LCM and HCF of these two numbers and the product of these numbers are same. This is the answer. Now the second sub question is 510 and 92. What we do now, we find out the factors of 510 first. We put blocks like this. Try with 2, 2, 2, 4 you get, and you get 11. 2 into 5 is 10, and again 2, 5 is 10. Further you have to try only with 5. 5 into 5 is 25, 5 into 1 is 5. Now you try with 3 now. 3 into 1 is 3, you get 21. 3 into 7 is 21. You can only try with 70 further. 17 into 1 is 17. You find that the factors of 510 are 2 into 5 into 3 into 17. This is the answer for the first number. Second is 92. For 92, again you have to try the same way. Put the blocks like this. Try with 2. 2 into 4 gives you 8. We have 12. 2 into 6 gives you 12. Try again with 2. 2 into 2 is 4. 2 into 3 is 6. You get 23. 23 does not have factors, so it has only one. 23 into 1. Therefore, the factors of 92 are 2 into 2 into 23. This is the set of factors we have for these two numbers. Now to find out the LCM and HCF, in the same way you need to try. We write down these two numbers together. Now we write down these two sets of factors separately. 2 into 5 into 3 into 17, the factors of 510, and the factors of 92 also we write down here. 2 into 2 into 23. Now you know to find out LCM, all you need to do is find out what is common. 2 appears to be common. Further, there is no number which is common. Therefore, the LCM of these two numbers is 2. You have to write only once. Balance you have to write as it is. 5, 3, 17, 2 and 23 you have to write as it is because they are not common. 5 into 3 into 17 into 2 and 23. It's a big number. When you multiply, what you get? You get a big number, 23,460 that you have to multiply. This is the LCM. LCM of these two numbers is 23,460. To find out HCF is very, very simple. That is, whatever is common, that is the HCF. Here 2 is common, so 2 is the HCF. Now the next step is you have to prove the product of these two numbers is equal to the product of the numbers. LCM into HCF is equal to 23,460 into 2. That gives you 46,920. 2 into 0 is 0. 2 into 6 is 12. Carry 1. 2 into 4 is 8. Plus 1 is 9. 2 into 3 is 6. 2 into 2 is 4. That's how you got it. This is the product of LCM and HCF. Now let us try to multiply the numbers. The product of two numbers is equal to 510 and 92. When you multiply this, you get 46,920. Now we know that when you multiply HCF and LCM, and when you multiply the numbers, then you get the same answer. This is our answer. Okay friends, now we are going to solve this third sub question in question number 2. That is 336 and 54. Let me write down. The third question is 336 and 54. As you know, the question says the product of LCM and HCF should be equal to the product of the two given numbers. In this, the two numbers are 336 and 54. First, what we have to do, we have to find out LCM and HCF of these two numbers. For that, the first step is, first take out the factors of each number. You know very well what is the way to find out the factors. Let us start from 2. 2 is dividing this number easily. 2 into 1 is 2. 2, 6 is 12. And 2 into 8 is 16. Now again try with 2. 2 into 8 is 16. 2 into 4 is 8. Again try with 2. 2 into 4, 2 into 2. Once again with 2. It goes 2 times and 1 time. Now you can try with 3. This is an odd number, so you cannot try with 2. 3 into 7 is 21. As you know, this is the last level and now it only goes, it is a prime number, so it goes only once. 7 into 1 is 7. Now write down the factors of 3, 3, 6. That is 2 into 2 into 2 into 2. 4 times 2 and then 3 and 7 into 3 into 7. The factors of 336 are this. Now we will find out the factors of 54. Similarly, write down factors of 54. As it is an even number, you can try with 2. 2 into 2 is 4 and it is 14 now. 2 into 7 is 14. Now you can try with 3. It goes easily 9 times. Try with 3 again. 3 into 3 is 9. Now this is a prime number. It cannot go further, so it is only once. 3 into 1 is 3. These are the factors of 54. Now write down that. The factors of 54 are 2 into 3 into 3 into 3. 2 into 3 cube are the factors of 54. This is the first step of answering the question. Second step is to find out LCM. You know very well, it is already taught to you to find out LCM. It is very easy. All you need to do is find out what is the digit or the number which is highest between these two factors. In this case, let us take 2. You have 2 only once, but here you have 4 times. So you need to take the highest number or the higher number of these two. 2 is once here, but it is here 4 times. So you need to take 2 to the power 4. Second is 3. Here we have 3, but here we have 3 cube. So you need to take 3 cube. Left with 7, which is not available here. So you need to take 7 once. When you multiply, you get 16 into 27 into 7. That gives you, if you multiply, it is 3024. So LCM of these two numbers is this. Now we'll find out HCF. It is further easy because whatever is common factor, you need to take that. Here 336 and in 54 we have only 2 as common and you have 3 as common. See? Now these 3 2's and 7 do not appear in the second line. Similarly, 3 square doesn't appear in the first line. Therefore, you need to omit it. So you need to write down 2 into 3. This is how you have to find out HCF. That is equal to 6. Therefore, HCF of these two numbers 336 and 54 is 6. Now we have to come to the last step, that is taking the product of LCM and HCF. That is our question. We are supposed to answer that. LCM into HCF is equal to 3024 into HCF is 6. If you multiply, you get 18,144. You try this. 6 into 4 is 24. Left with 2. 6 into 2 is 12. Plus 2 is 14. And left with 1. 6 into 0 is 1. Then write on that. 6 into 3 is 18. That's how you got this number. Now question says product of the two numbers. The product of two numbers. Which are those two numbers? 336 and 54. So you multiply the product of two numbers is equal to 336 into 54. If you multiply, you get the same number again, 18,144. You try that, you get this number. Therefore, the answer is the product of LCM and HCF is equal to product of the given two numbers. So we have arrived at the answer. The third question is find the LCM and HCF of the following integers by applying the prime factorization method. There are three sub-questions here, 12, 15 and 21 is the first question. We will solve now one by one. Now write down 12 to factorize. You take 2, 2 into 6 you get 12. Again try with 2, 2 into 3 you get 6. And now only once you can try because the prime number 3 into 1 is 3. The factors of 12 are 2 into 2 into 3. Now you try with 15. For 15, you can try with 3, 5 times, only once. So 3 into 5 is 15, 5 into 1 is 5. The factors of 15 are 3 into 5. Now go for 21. Factors of 21. You know very well, 3 into 7 and 7 into 1. The factors of 21 are 3 into 7. Now we have taken all the factors of these two numbers, three numbers. Now we will find out LCM and HCF of the three numbers. How to find out LCM? You know very well. LCM is equal to whichever is the highest number here, that you take. For example, here we have 2 square. That 2 square you have to write down here. And you have 3 in common, that is here and then here. So you need to write only 1 3, not all the 3. There are 3 3's here. You have to take only ones, 1 3. 5 and 7 as it is you have to repeat. Now if we multiply, let us take 60 into 7. 2 to the 4. 4 into 3 is 12. 12 into 5 is 60. into 7. 7 into 7, 6 into 7 is 42 and 0. You get LCM of these three numbers, which is equal to 420. Now HCF. HCF is easy to find out. What is common? That you need to write down. 3 is common, so 3 is the HCF. That is our answer for the first question. Now let us try the second question. Here again we go for 17. 17 is a prime number. So 17 does not have more factors except 17 itself. And then 23. 23 is again a prime number. You cannot get more factors. Write down 23 as it is. 29 again is a prime factor. Therefore, the factors of these three numbers are the numbers itself. You need to find out LCM now. You need to multiply all these numbers, 17 into 23 into 29. When you do this, you multiply. I have already done this. You get answer 11,339. This is the LCM. Now what is HCF? Please be aware that when we don't have any common factors, in this case you know it is 1 into 1 into 1. So 1 is common. Sometimes we don't write 1, but when we need to come to find out HCF of such numbers, then you should be very careful to find out what is common. Common here is 1. 1 in all these three cases. So 1 is HCF of these three numbers. This is the second question. Third question is again easy. Let us find out for 8 the factors of 8. 2 into 4, 2 into 2 and 2 into 1. Therefore, 8 is equal to 2 into 2 into 2. And for 9, 3 into 3. Again 3 into 1. So factors of 9 are 3 into 3. Lastly, 25. 5, 5. 5 into 5 is 25. 5 into 1 is 5. For 25, you write down 5 into 5. Now LCM. LCM is, in this case, 2 cube. And in the second case, it is 3 square. In this case, 25. And then multiply 2 cube into 3 square into 5 square, that is 25. You get 1800. LCM of these three numbers is 1800. Now go for HCF. Similar to the previous question, here also you don't find anything in common. Therefore, all you need to do is take 1 as common factor. So HCF of these three numbers is 1. So now we have solved question number 3, and in that we have solved all the 3 sub questions. Okay friends, now we are going to move on to the question number 4. Given that HCF of these two numbers as 9, find LCM of these two numbers. Now you know the relationship between HCF and LCM of any given two numbers. What we have to do, let us write down what is given. In this question, they have given HCF, which is 9. This is the HCF. Right? Now you have to find out LCM. What is LCM? We know very well, and we have done in the previous questions, the product of LCM and HCF is equal to the product of numbers 306 and 657. Now, we know this, therefore, we leave LCM in the LHS, write down the product of these two numbers, write down those numbers as it is. Product of these two numbers. These numbers we are writing and taking HCF to the denominator side. HCF is 9. LCM is equal to the product of these two numbers divided by the HCF. This is how you get the LCM of these two numbers. When you simplify, you get 9 into 3, 27. Left with 3 and 6, 36. 9 into 4 is 36. So it goes 34 times. Now when you multiply 34 and 657, you get 22,338. When you multiply 34 and 657, you get 22,338. This is the answer. The question says find out the LCM. So we have found out the LCM of the given two numbers, that is 22,338. Now we move on to question number 5. Question number 5 says check whether 6 to the power n can end with digit 0 for any natural number n. By saying this, you may get a bit confused how to find out the answer for this. It is very simple. All you need to do is, you know very well, to get 0 for any number, you need to have 2 into 5, which is equal to 10. If you have this pair in any given number, then you can expect 0 at the end. Suppose you have 2 into 5 and one more set of 2 into 5, then you get 10 into 10, you get 100. So again you have 0 at the end. Similarly, you can see that either one pair of 2 into 5 or under two pairs of same 2 into 5, you get 100. To get 0 at the end, you need to have a pair of this number. This is a compulsory one. But in this case, let us go in the given number 6 to the power n. Factorize 6. 2 into 3. 6 is equal to 2 into 3 whole to the power n. Let n be any number. In the beginning itself, we know that 2 into 3, it does not have any pair of 2 into 5, so that the number ends with 0. This itself is the proof. I repeat, 6 is factorized, 2 into 3 is 6, whole to the power n. We have n here, so whole to the power n. Now you see, there is no pair of 2 into 5. 2 into 5 gives you 10. Or two pairs of 5 into 2 gives you 100. At the end, if you want 0, you must have this pair. Is either in pairs or at least single pair. But in this case, you don't see any pair of 2 into 5. Therefore, this number 6 to the power n does not end with 0. Let us write down this. The answer is 6 to the power n does not end with 0. Let us write down the reason. Because the factors do not have the pair of 2 into 5. So this is our answer. 6. Question number 6 says, explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. You need to explain why they are composite numbers. Now I have to explain you what is a composite number. I think you all know a composite number is a positive integer. Any positive integer which should have at least one divisor to divide that number other than the number itself and 1. I just give an example before answering this. Let me take another paper. I'll explain you. Suppose if I have one number, say 25. Now I can take the factors of 25, which is 5 into 5. Now this number can be divided by 25 itself. That is 25 by 25, you get 1. So this number 25 can be divided by the same number, or it can be divided by 1, which is equal to 25. It can be divided by 1. So these are the two conditions. Now further, if you have any other divisor, in this case 25 can be divided by 5. 5 into 5 is the answer. Now this number has one more divisor, that is 5, to divide this. In this case 25 is a composite number. Now similarly, in the given question we have two numbers. Let us take one by one. First number is 7 into 11 into 13 plus 13. Now what you have to do? You have to simplify this. Now this is one term, this is another term. Let us take 13 as common factor. You can do it whichever way you want. I do this way. I take 13 and balance I write down 7 into 11 plus I write down as it is, and here is 1. When you take out 13, this is what the balance. Now I write down 13 into 77. 7 into 11 is 77 plus 1. 13 into 78. Now if you multiply, you get 1014. Now I would like to tell you, this 1014 is a number which can be divided by the same number. I write down here 1014. You can divide by that number itself one time. Okay, condition number 1. Second condition, 1014 can be divided by 1. 1014 will be the answer. This is second. If a number does not get any divisor further, then this number cannot be a composite number. But in this case, you have 1014, you can divide by 13 because 1014 has two factors. You can divide by 13, you get 78. Now we have one more divisor, that is 78. Same 1014 can be divided by 78 also, 13 times. This is the two factors you have other than 1 and the number itself. Therefore, the given number is a composite number. Let us go for the second. 7 into 6. Further, we write down 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. You can write down here also, we have one 5 common, one more 5 common. This is one term, this is another term. In this we have 5 and after plus you have one more 5. So let us simplify this way. 7, 6, 4, 3, 2, 1. We write down. We can simplify now only. 7 into 6, 42 into 4 into 3 is 12. 12 into 2 is 24. And then plus 1 because I have taken out 5. Now further, we have to simplify. What is 42 into 24? You get 1008 plus 1. Now 5 into 1009. If you multiply, you get 5045. Multiply 5 and 1009, you get 5045. Now let us try whether this is a composite number or not. 5045 can be divided by the same number once, and the same number can be divided by 1. You get 5045 answer. So these two are already there. Further, if you have any other divisor, you need to find out. You have 5 and you have 1009. If you take 5045, you can divide by 5 and you get answer 1009. And if you have 5045, you can divide by 1009 also. There you get 5. Because you have two factors 5 and 1009 other than 1 and the same number. Now these two numbers, the first number and the second numbers, are composite numbers. You can write down both numbers are composite numbers as they have two factors to divide them other than 1 and the number itself. So please find out. This way you get two factors for both numbers. Two factors for this, two factors for this, and that is why these two numbers are composite numbers. This is the answer. Okay students, we are coming to the last question. I'll read out. There is a circular path around a sports field. Sonia takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes for the same. Suppose they both start at the same point at the same time and go in the same direction. After how many minutes will they meet again at the starting point? For this, the question is very, very big, but the answer is very small. All you need to do is to find out LCM of these two numbers, 12 and 18. 12 and 18. LCM of 18 and 12. Now 18 factors. 18 factors. You start from 2. 2 into 9 is 18. Now 3. 3 into 3 is 9. Now 3 is a prime number. You get only once. 3 into 1 is 3. Now factors of 18 are 2 into 3 into 3. Now 18 is over. Let us go for 12. Now we write down here 12. 2 times. 2 into 6 is 12. Try 2 into 3 is 6. 3 into 1 is 3. 2 into 2 into 3. These are the factors. 18 has 2 into 3 into 3 and 12 has 2 into 2 into 3. Now the LCM of these two numbers. How to find out? You know very well. This is 3 square. You can also write down this 2 into 3 square. This is 2 square into 3. Here, out of 2, which is bigger number, 2. So write down this 2 square. LCM is equal to 2 square into, out of this 3 square is the higher number. So write down that. The LCM will be equal to 4 into 9, that is 36. The answer is they take 36 minutes to come to the same point, both together. Now the question is answered, but I still want to continue by explaining what is the meaning of this, and let us try to find out will that be possible. So now this is only explanation. Sonia, she starts from point A of the field, goes round the field, comes back at the same point. She has completed first round, and now for this she has taken 18 minutes. The question has given you this clearly. She takes 18 minutes to start from a point, go around and come back to the same point. First round is over in 18 minutes. The same girl goes for the second round, comes to point A. This is second round. Now she has taken another 18. 18 plus 18 is 36 minutes. In this 36 minutes, she has completed 2 rounds. Now, when Ravi also starts from A along with Sonia, this girl is completing in 18 minutes, but Ravi has gone further because he has taken 12 minutes to go. She has completed 12 minutes and then he is further somewhere here. That means he is faster. So let us write down one round of Ravi. She takes for the first round 12 minutes. For the second round, she has taken 24 minutes. 36 minutes is the time taken by Sonia for the second round, but this person has taken 24 minutes. Now he has still some more time, that's why he has gone for the third round. 24th minute onwards, he has started going for the third round, and by the time 36 minutes completed, this boy has come back to A after completing 3 rounds. This is one way of explanation. Another way is, let us take the tables, 12 table and 18 table. You know very well the table 12 table has 24, 36, 48, 60, 72, 84, 96, 108 and 120. This is 12 table. In 18 table you have 36, 54, 72, 90, 108, 126, 144, 162, 180. Just understand what is the real meaning of LCM. In this table you have 36 and in this table you have 36. Let us write down separately. In this table you have 72. Here also you have 72. Again you have 108 here, which is common in both tables. You write down 108. Now these are the multiples of 18. These are the multiples of 12. In common, you have 36, 72, 108. These are the common multiples. Common multiples. Out of these three, the least is this, or the lowest. And that is why we call this as LCM. I hope you understand what is the meaning of LCM. And in the first case, Sonia has taken 36 minutes to complete 2 rounds. Ravi has taken 3 rounds in 36 minutes. The answer is the LCM of the question, that is 36 minutes. You can write down both take 36 minutes to meet at the same starting point. This is the answer.